I'm Dan Duncavage, and welcome to the briefing. Now, as I sit here today, I'm right between two very consequential weeks. Last week was the 40th anniversary of the Space Shuttle Challenger disaster. Next week, however, is the opening of the launch window for Artemis II to carry 4 astronauts to circumnavigate the moon for the first time since the 1970s. So a consequential time. I'm thinking about my 29 years at NASA as a civil servant in the space station program and all of my experiences throughout some of our strengths and our weaknesses, our successes and our failures. There are many stories I have to tell and many insights and suggestions for the future that I hope will be a valuable addition to the conversation about how to make our space agency as best place that it can possibly be. So let's jump right in. Now, when the Challenger disaster occurred, I was a freshman in engineering school in Boston. 8 years later, I had had some experience with some defense contractors, and I had earned a bachelor's and a master's in engineering, and I was able to join NASA in 1994. Some months later, I was in Moscow, or just outside Moscow actually, in a meeting with RSC Energia, which is the prime contractor pretty much for the Mir space station, for much of what the Russian Space Agency does. Now, the Mir space station was the space station that the Russians had from, I think, late 1980s until for about maybe 15 years before it was used up. Maybe it was 20 years, and then they deorbited it. So when we started our space station program, or restarted it after Space Station Freedom, I used to joke that the Clinton administration canceled Freedom. Now, what had happened was the Space Station Freedom program was way over budget and late, and it was canceled and replaced with the International Space Station, which was going to be bigger, better, and supposedly cheaper, but it was more expensive. Anyway, one of the big pieces that we did was we added the Russians to this whole mix, and the Russians were going to bring a whole part of the space station, starting with the Functional Cargo Block, or FGB. And that was the main propulsion, guidance, navigation, control, attitude control module, the first thing that was launched. So we bought that from the Russians. We also bought some high pressure, not high pressure, but pure oxygen pumps for our airlock, some other bits and pieces, and we bought a lot of data. We bought a lot of their historic long-term flight data, because they had been flying space stations more than we had. We had just had the Skylab in the 70s, but they had a series of Salutes, and now the Mir. The Mir, by the way, is Russian for peace. And so that space station, we decided we wanted to go up and practice on it. We would fly space shuttles up to the Mir space station. We'd dock to that space station, and an astronaut would go on board, spend a long duration mission there, do science and the like, and then come down. We'd bring up logistics and such. Now, to do the docking, we used Russian docking mechanisms called APAS, Androgynous Peripheral Assembly System, if memory serves. Anyway, so we bought those, and I was part of that contract team. I was like technical person in the contract management team. And so I was over there supporting the Mission Science Working Group, which is where they were planning the science and executing science on board, and also the Russians were giving us some of their previous scientific data and astronaut data and the like, cosmonaut data rather. And so I was there at a meeting. We were doing these roughly quarterly at the time. And at that point, in 1997, in July, that's when the Progress M34 crashed into the Mir space station, specifically into the Spectre modules, punching a hole in it. And the cosmonauts and the astronaut had to rush over, and they had to close the hatch. They had to do a whole bunch of things to allow the hatch to close and seal off the Spectre module, and it was lost to our ability to use it. It remained attached, but it was depressurized and unusable. This was a big problem for the Mission Science Working Group, because most of our experimental hardware and everything that we were doing was pretty much in Spectre. I think the astronauts' clothes were in there as well. There was a whole bunch. So I was the one who had to then lead the effort to assess how much money it had cost America and to negotiate with the Russian Space Agency for an equitable adjustment to cut down the contract cost or get other things. We never reduced the contract, we just got more things, like more missions and the like. Now, why did this happen? Why did Progress M34 crash? Well, it crashed because they were trying to save money and other things I'll get into. So they were removing a thing called the KERS automated docking system, which was expensive, but more importantly, it was made in Ukraine. And the Russians and the Ukrainians were arguing. Sounds familiar, doesn't it? Well, that's what was going on. And so they wanted to remove this. They were going to run a test. Gosh, this sounds like Chernobyl. We're going to run a test and a disaster occurs. So anyway, they decided to take a Progress that was already docked, undock it, bring it around, and then redock it. And this time, the redocking, they were going to have the KERS turned off, and they were going to have a cosmonaut sitting inside the space station guiding it in. Now, they didn't have a bore sight centerline camera, and I don't think they had any cameras, actually. It was trying to look out the window and look at telemetry and do this, and it was a really sketchy thing to attempt to do. And NASA had warned Russia, please do not do this. This is a terrible idea, and it had debates about this. But the Russians moved forward with it. So this brings up this point of ignored warnings. Now you're going to see this every time something bad happens. Someone is going to say, hey, I warned you. And it's probably true. The thing is, every time something goes good, somebody warned them that it was going to go bad. Anytime you do something difficult, there's a possibility it'll go wrong, and there was always a good logical argument for why this is a terrible idea. Every time. So your culture and your leadership have got to be able to figure out, how do I divide the valid complaints from the invalid ones? And of the ones that are valid, how do I mitigate that risk, or overcome that risk, or retire that risk in some way? This is a difficult thing to do. If it weren't difficult, we'd never have disasters, we'd never have mistakes, drugs would always work, and no company would ever go out of business. But it's hard. So anytime you hear something goes wrong and there was some whistleblower that said so, and this is a terrible organization because they didn't listen to the whistleblower, it's not that simple. It's never that simple. So let's move forward to the Columbia disaster. So in 2002, STS-107, Space Shuttle Columbia, re-entered and broke up. And there's a lot to be talked about that. Now at the time, I ran a software R&D team, and we were developing automated prognostic and diagnostic systems to try to improve ISS operations and future operations of complex vehicles. So I wasn't directly involved in that. But I had a good number of close friends that were involved in the Columbia Accident Investigation Board support team, and a friend whose sister was aboard Columbia as one of the astronauts. So debate over the CAIB, Columbia Accident Investigation Board recommendations, that debate endures to today. Did we really take on the recommendations correctly? Did we improve our organization the way we should, or did we not? I'm on the side that we didn't do a lot of the right things, and not from negligence. NASA took this really seriously. Everyone around me did. Can't think of anybody who was blasé about safety or was a cowboy. I mean, that's just not how NASA engineers are, or managers. That's just not the way they are. It doesn't mean we made the right changes. People have a hard time changing how they think. You're going to hear that again and again. So we had many new processes. We created new safety organizations, new safety documentation, new requirements. We had a lot of bureaucracy. We already had bureaucracy, we added more. We had paperwork, we added more. I would argue we didn't make better space stations and better space systems out of that, despite seriously trying. And we're going to talk in these various episodes about how you think about this. One of the other things I noticed is that some of the exact people who were there, not just there, but really responsible for some of the bad decision making on Columbia, ended up running some of these organizations. You may first knee-jerk react, like, why didn't we just fire all these people? And there's something valid to be said for some of that. But also the idea that, well, look, you've been through it. You know in detail what happened and where your mistake was. And again, nobody was flippant about this. So anybody who was directly involved in, I feel really awful about this and really committed to doing it right. The problem is, the way you think, the fundamental way you go about approaching a problem usually doesn't change, and I didn't see changes in many people. And I think that that's where the problem is. They may have had the deepest level of knowledge, but they also had the wrong mind map. And I think that that's where we ended up with problems. I'm going to talk a little bit next about a subject that I probably have a lot of funny stories. One semi-funny story there at the end. And this is board meetings. Now, NASA doesn't make decisions just by one person. Decisions are always made at boards or panels. A panel is like a mini board, and they have this pyramid of boards up to the top one in any program. Now, the CAIB report said that we were too reliant on PowerPoint pitches for technical presentations to boards, as opposed to writing white papers, having everybody read the white papers and then get together and discuss it. I would agree with that. I thought that that was really a problem. Now, when a board gets together and meet, the chair is the only one that actually has a vote, and the chair can simply make a decision, but that doesn't happen. Chairs always want to see consensus across all of the board member representatives. And you'll have representatives from the various stakeholders. It might be payloads, maybe flight operations, maybe there's always be a safety representation. It could be international partners, whoever, crew. Different groups right around the table there, and you want to make sure that they all agree with you. And there's a good reason for that. You don't want to just go trampling off in a bad idea when the ops guys are yelling, hey, I'm not ready to do this, or I don't have the right procedures, or what have you, or safety saying it won't work. So it's all very reasonable. That's the thing you'll notice. There's never anything unreasonable or ridiculous. However, we somehow managed to get to crazy town, and I'll talk about that quite a bit in future episodes. So anyway, the presenter gets up there, and they bring a PowerPoint chart deck and they go through it. Now, the wise presenter will have previously coordinated with the main players, or more probably the technical team that's backing up those board members. And I've seen some incredibly complex diagrams and PowerPoint charts, some real PowerPoint Michelangelos with just an immense amount of data in one picture. I've seen that. But these PowerPoint charts generally had, chart after chart after chart with a bunch of bullets and not a lot of information. Some had some significant amounts, but most really there was very hard to follow if the person wasn't there talking. So that means this presentation would be there in the minutes, but all the words weren't there. So you go back and you read one of these things and you're like, why did we make this decision? I see these kind of half-assed bullet points. So that was a problem. So I tried following the CAIB recommendations, bringing white papers to meetings, but that was not what the culture wanted, and I was directed by management. No, you have to put this in PowerPoint, and here's a standardized format to use. My workaround was to say, all right, I'm going to use full sentences, not bullets, and then I'll put an appendix with all of the white paper-like information, and I required people on my team to do as such. So at least it could be just read, and you could understand what the heck was going on. Now, speaking of whether or not you're using PowerPoint to make a decision, you could argue that, look, the presenter needed to get agreement of working level people usually below the board seats. So technical detailed questions would have been ironed out. And to some extent, this was true. But much of that pre-coordination consisted of discussions on format or editing, wordsmithing, editing words. Sometimes personal conflicts, political issues. It was not as much technical as it could have been. That happened a lot. Worse, remember, these boards would go in this hierarchy. So every time you would go to a higher level board, you'd have to rewrite your charts, put them in a new format, negotiate with new people, get different managers to agree to how you're saying something. A lot of time was spent chart smithing, as we used to call it. High-level boards would usually have a pre-board meeting, so a meeting before the meeting where the board chairman, the presenter, and maybe a couple of other people would kind of go through it, and they'd sort of make the decision ahead of time. So that made the board meeting more of a theatrical production than an actual discussion. I always wondered why we bothered with these formal meetings. To me, the process felt like it was a responsibility diffusion mechanism and a social event for managers. Now, supporters of the status quo, they didn't really agree with this, and they had points because you were making sure that full communication was there and that everybody, all these board members formally said, yes, I understand what we're doing and I concur with it. So there is something to be said to that, but the weight of the system was very large. And supporting a weighty system like that, it ends up being a zero-sum game. When you have to do that, you could have been doing engineering, but you did PowerPoint engineering instead. So that was a bit of a problem there. I'll tell you a story, though. This is the funny one. So this is a very important meeting. This is the ISS Mission Management Team. Now, the MMT is where operations and the program come together and they make decisions. And these meetings, at least to a certain extent, can hold, I think, daily. But then there are major meetings a couple times a week. We'll discuss bigger things or more things. If memory serves, the increment lead flight director and the ISS deputy PM for ops would run these board meetings. And you'd have everybody there, of course, all the different representations, IPs and all that kind of thing. So I was there to present at one of these meetings, and while I was waiting to go, there was a presentation being given by someone who was not in the room. I think they were at Marshall Space Flight Center over in Alabama. And so you've got speakers that are playing the person's voice, and then up on the big screen there's their presentation, and he's going through his charts and talking, right? So I look around the room, nobody's looking. Everybody has got their head down, either on their phone or they're doing email, or nobody's paying attention, including the board chairs who have their mics on mute and they're chatting. Nobody is paying attention to this presentation. So why in God's name were we even doing this? So I asked the purpose of the meeting. Why are we doing this? Not in that meeting. It would have been bad for my career. It was bad enough for my career that I would ask questions like this. But why are we doing these meetings? Nobody's paying attention in this meeting. It didn't really matter. We had already decided before the meeting that we were going to go ahead and say yes to this thing. But it was told to me, hey, this is the formal program go, no-go decision for operations and program. It's absolutely essential. Formal, certainly. Essential? If you're a bureaucrat, I guess maybe you'll consider it to be essential. But to me, the meeting, it was theater. A lot of the meetings are. And that wouldn't be bad, except that it takes a lot of people's time that could have been spent designing better space vehicles. And again, NASA's not just a bunch of idiots who don't care. Everybody in that room, if you sit down and ask them questions, they're going to know a lot. And they really do care about what they're doing. But we ended up putting so much process bloat in the way, it ended up costing us. And that's why space station costs so much, takes such time. It also hurts us in terms of leadership. That's the briefing for today. Now we're going to go into more stories, and we're going to look at more detailed events that went on, and more ways that NASA could be better, and could in fact be, as you will hear in the future, better, faster, and cheaper. If you like this, please like and subscribe, and I'll see you next time. Thank you very much.